pause the video while you write down your answer to this question. Okay, so mentioning it can be treated as graph coloring problem with 6 colors. We want to, when we're describing these approaches, it doesn't say do pseudocode. We want to make sure that we describe how the ADTs are representing realities. So each color represents a different component type, and each component can be modeled as a node of a graph with the connections as components represented as edges. So that's all fairly clear. Now, there were 2 different ways you could have interpreted this. Either we are checking to see if a given structure satisfies a condition, which is the first bit here, that was accepted, or we do what's called a greedy coloring algorithm, which you're going to see again in this session, even though it's actually in a Unit 4 thing. And I'll just show you what this looks like. So let's imagine we've got our graph. I thought the question was a bit misleading actually, because it says there are 6 separate components, but we're told that there are structures of any size. So I think it means there are 6 different types of components. And so essentially we're doing a graph coloring problem with 6 colors. I'm just arbitrarily joining in some lines here for fun. Okay, and the way we do this, we will color the first vertex with the color number 1, and then each neighbor we're going to color with the lowest number that will not give it an adjacent vertex with the same color. So we can color this one 2. We can color this one 2 because there's no 2 next to it, and we can color this one 2. Now down here we could color this one number 1. We could color this one. We can't color it 2 because there's a 2 near it, so we'll color it 3. This one we can't color it. Well, in fact, we can color it number 1 because it's not next to anything else. I'm going to do this in a, well, who knows, a mixture of breadth first and depth first. This one down here can be number 2. This one here can be a 2. This one back here can be a 1. This one could be a 1 because that 1 is not adjacent to anything else. We've got considering this vertex, we've got a 1 and a 2 next to it, so this would be a 3. This one here can be a 1. This one here can be a 1, and it's next to a 2. Now, I wouldn't do diagrams. If it says describe, doing a diagram is a bit risky, and doing this diagram and just leaving it like that is kind of useless. Like I've done that to aid the explanation. If you were going to do a diagram to try and explain it, you'd need to show multiple diagrams and show how it's built up in layers. But if you can, practice writing the explanations. That's better than relying on diagrams.